This is our video for section 3.7, and this is starting to think about function notation. So if you remember, a function means that each input, which are our x values, goes to exactly one output, which are our y values. And so we're going to start looking at the way that we write this. We're not really doing anything new, we're just doing it using different notation. So we've talked a little bit about how the equation of a line can be written in this form, y equals mx plus b. And when we start using function notation, the only thing that's really different is instead of y, we're using this f of x. So when we write this, the f and then in parentheses x, what we say is f of x, and that f stands for function. So these two things mean exactly the same thing. Just instead of y, we're writing f of x, and that tells us that it is a linear equation, and specifically it is a function. Again, reminder, x is our input, and since y is being replaced with f of x, that is now our output. So again, f of x means the same as y, but it is a function. So in example 1, we are evaluating. So it says evaluate f of x equals negative 4x plus 7 when x is 2 and when x is negative 2. So this is two different things. And so all we want to know is, what is this equal when x is 2? And so instead of x, we're just going to plug in 2. And notice how this says f of x. So when x is 2, we're going to rewrite this a little bit different as well. We are going to say f of 2, since we know that x is 2. So negative 4 times 2 plus 7. So then f of 2 is, so negative 4 times 2 is negative 8 plus 7. That would be negative 1. So f of 2 is negative 1. And that's how we would say that. We would say f of 2 is negative 1. Or equals negative 1. Either way is fine. And what this means is, when x is 2, then y is negative 1. Or that's basically, it's a solution to this equation, right? If x is 2, then f of x is negative 1, which means the same thing as y is 1. Again, we're really not doing anything different. It's just wrapping our head around this notation and the way that we say things and the way that we use this. So we also want to do the same thing when x is negative 2. If you're doing this for the first time, I would recommend pausing and trying this on your own, and then coming back and watching. So when x is negative 2, we'll say f of negative 2 is negative 4 times negative 2 plus 7, which is going to be 8 plus 7, which is 15. So f of negative 2 is 15. Or, same thing is, when x is negative 2, y is 15. Example 2. I'm going to do some interpreting. So let f of t be the outside temperature t hours after 6 a.m. Okay. So f of t be the outside temperature t hours after 6 a.m. Okay, so both of these things are really important. So our output is temperature. Our input is number of hours after 6 a.m. So let's split these up here. In the first one, we have f of 0. So that tells me that t is equal to 0 And f of t is equal to 58. So remember, t is hours after 6 a.m., so 0 hours after 6 a.m. is 6 a.m. And then our temperature, f of t, is 58 degrees. So if we're interpreting this, we could say something like this. At 6 a.m., the temperature is 58 degrees. Second one, f of 6 is equal to n. So again, this is our variable, this is our value of t. So if this is, we want 6 hours after 6 a.m., so that would put us at 12 noon. And then this represents our temperature, n. And even though that's not a number, we can still say what this represents. So at noon, the temperature is n degrees. Number 3. So both of these represent temperatures, right? Because remember, f of t is the outside temperature. This is a time, this is a time. So one temperature then, the temperature on this side, is less than this temperature over here. So we got to think, when t is 3.5, what time is it? So that's 3.5 hours after 6 a.m. So actually, let me think, I want to say this a little bit differently. So this time on the left is going to be 9:30 a.m. And the time on the right is 6 a.m. plus 9 hours. That's going to be 3 p.m. So what this means is the temperature at 9:30 a.m. is less than the temperature at 3 p.m. Moving on. Find h of x, for h of x, which equals 2/3 x minus 5. Find the value of x for which h of x equals 7. So remember, this is basically like saying y equals -7, and now we're looking for the value of x. So when I rewrite this, instead of h of x, I'm going to write -7. And I'm going to solve for x. So getting x by itself, so this is going back to chapter 1. I need to get rid of this -5, and I need to get rid of this 2/3. We always do the term that's attached to that variable last, so I'm going to get rid of the -5. I'm going to add 5 to both sides of my equation. So -2 equals 2/3 times x. That's what that means. 2/3 x is 2/3 times x. And you could do this in 2 steps to get x by itself. We could multiply by the 3 and then divide by 2. It's easiest, though, to just do this in 1 step. When I'm trying to get rid of that fraction that's being multiplied by x, I can just multiply by the reciprocal, the flipped fraction. And if I do it to one side of my equation, make that a little clearer, my equal sign a little clearer, I need to do that to the other side as well. So let's kind of refresh on why this works and what happens when we do this. Okay, so here I'm going to kind of expand on this step here. On the right side, what happens when I take 2/3 times 3/2? When we multiply fractions, we go straight across the top, straight across the bottom. So 2 times 3 is 6. 3 times 2 is also 6. Any number divided by itself is 1. And so when I multiply those two fractions together, it turns into a 1, and 1 times x is just x. X will be left all by itself. On the left side of the equation, I've got 3 over 2 times negative 2. And that's a whole number, negative 2. I always like to write that as negative 2 over 1, so that when I'm multiplying a fraction, I'm multiplying it with another fraction. Again, multiply straight across. 3 times negative 2 is negative 6, divided by 2 times 1 is 2. Simplify, that's negative 3. So on the left side, we have negative 3. On the right side, we have x. So when h of x is negative 7, x is 3. It's the same thing as we did up above, and we're just substituting in for a different thing. We're basically substituting in for y instead of substituting in for x. Final example, we are going to graph this function. So it says f of x is equal to 2x plus 5. So when we have this, we just need to choose some x values, and then solve for the corresponding y value. And of course, then we'll plot those points. I only need 2 points to define a line. I'm going to find a few more just to kind of show you how this works and make sure that you have a couple examples. It's always good when we're trying to graph to choose a couple different points. I always like to choose a negative. It's usually a good idea to choose 0 or 1. So here's what I'm going to choose. So I've got x values, and then we've got f of x, which, remember, that's just the same as y. Same as our y, and when we plot it on the graph, that is our y value. So for x, let's choose negative 2, 0, and positive 1. So what we're going to do is we're going to just plug those values into our equation and find the corresponding y value. So I'm trying to figure out where I want to do this. Let's kind of do this over here on the side. So for when x is negative 2, we would have f of x equals 2 times negative 2 plus 5, which is 2 times negative 2 is negative 4, plus 5 is 1. Probably should have written this the same way that we did it earlier. That would make things a little clearer. So f of negative 2 is 1. And we do the same thing for 0 and 1. So f of 0 is 2 times 0 plus 5. This works out really nicely. This is a reason we always choose zeros, because that's going to make this term go away, because 2 times 0 is just 0, plus 5 is 5. So f of 0 is 5. And we'll do one more just for fun. F of 1 would be 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. So f of 1 is 7. Again, if we know it's linear, we really only need 2 points. But let's just plot all 3 of these again, just so we have a little bit extra here. So my x value is negative 2, and that goes with a y value of 1. So negative 2, comma 1, there's my first point. Then 0, 5 as a second point. And 1, 7 is a third point. And if we did this correctly, trying to make sure that I can line this up really nicely, we should have a nice straight line that just goes through all of them. And that's how we do our graph.